Welcome everybody to another episode of Software Architecture on Stream. This time around with Daniel. Hi Daniel, welcome to the show, and I'm glad to have you on the show. Before we start, one of the reasons why Daniel is here is because he's doing a keynote at OOP conference next week. So I'm really looking forward to that. And during OOP conference, we will do more streams. So there will be a stream on Monday evening, the English evening, where we will have a few English episodes. There will be a stream on Tuesday during the lunch break, where we will have 3 short sessions in German. And then on Wednesday we will have a climate panel, and on Thursday we will have a panel about diversity. So we will have 4 episodes, more than 4 episodes even, next week, and I'm really looking forward to welcome you there and see what we discuss there. So again, Daniel, thanks a lot for showing up, and I'm really looking forward to your talk at OOP conference next week. So do you want to say a few words about yourself, what you're doing, and who you are?
Hello. First, thanks for having me on your broadcast. This is great fun. So for those who don't know, Eberhard and I go back a long way. We've known each other quite a long time. But this is the first time I think it's the first time you've interviewed me, or we've had a kind of conversation on air. And we share a lot of opinions, I think, and we disagree on some interesting things as well. So always a lively way to have a conversation. So I'm Daniel. I've been in technology for about 30 years as paid employment, which was started as programming and then going into tech leading and consulting. Did quite a lot of consulting with ThoughtWorks, which is a global software consultancy. They were quite a lot smaller in the early 2000s when I was there. And on the way through, I accidentally came up with behavior-driven development, and then was a significant part of continuous delivery. So my technical background, I guess, is about helping teams produce better results, and about the kind of the holistic end-to-end of software. So it's not just about code and coding and design, it's about how that gets into production. So all of the DevOps piece and all the path to live. Last 10 years or so, I've been very much more in the organizational side of things. So if you think of my career as panning back, I start at a keyboard in modules of code, I pan back to a team, I then pan back to groups of teams, and now I'm like looking at organizations. But I still love programming. I still get very excited by programming. One of my favorite things, quick shout out, is Advent of Code. And what I do with Advent of Code each year is I use that to learn a thing. So 2 Christmases ago, I taught myself Kotlin using Advent of Code, and over this Christmas I was looking at Rust using Advent of Code, and I didn't get past day 3 because I'm still learning how borrow checkers work.
Okay, sounds really interesting. So today we are going to talk about Solid and Cupid, and I was wondering, what is your sort of personal relationship to that? Why is it important to you, and why are we talking about this subject today?
That's a fascinating question. It really wasn't all that important to me. So let me start there. This is a few years ago, 2017. I gave a 5-minute lightning talk, and it was the point of the lightning talk is it was supposed to be fun and silly, and it was in a pub, and the way that all the talks were scored was how loudly drunk people cheered. Okay, so. And I decided for my 5-minute talk to unpack Solid. So for those who don't know, Robert Martin, who's the pioneer of clean code and this sort of software craftsmanship movement, he has, from 20 odd years ago, I think, a list of over 100 kind of coding principles that he considers clean code. And a chap called Michael Feathers noticed that the first 5 of these, if you arrange them in a particular order, spell the word solid. And so they became known as the solid principles. So they're 5 principles of software development particularly object-oriented software development, that have kind of become canon. So I was looking at these, and my first take on these was they are neither necessary nor sufficient. In other words, I've seen really good code that violates every one of the 5 solid principles. I've also seen code that vehemently adheres to all 5 of them and is unworkable and is completely unmanageable. So you know, they seem to be like some interesting, useful observations. Now, to be fair, they are also a valuable historical document. So I think when they and the rest of those principles were coined, was a time in object-oriented programming when 2 things were going on. One is you had an explosion in programming generally. You know, you can look at this exponential growth in programmers. And one thing that Bob Martin has observed is that because we've got this exponential growth in programmers, most programmers have less than 5 years experience. You know, and that's true at any point in history. Right? More than half the programmers you work with have been doing this for less than 5 years. And so he wanted to produce a list of kind of guiding principles, really, to help people write better code. And what they seem to capture as a time capsule is what people thought was good object-oriented programming and it has to be said as well, class-based object-oriented programming. So Solid would apply much more to like a C++ or a Java or a C# than it would to a Smalltalk or a Ruby, for instance. And we can talk a bit about that as well. But these are, like, for me, they're a useful historical document. But like the underlying, the foundation of these principles, I think, has changed dramatically over the decades since they became canon, to the point where they're not just redundant, they're actively harmful. And so anyway, so this whole thing, like I say, was a 5-minute silly throwaway talk. And I made the mistake of putting it online, the slides at least. So now you've got the slides from a lightning talk. So you don't even have my narrative, you've just got the slides. And a bunch of people calling themselves software craftsmen got very upset that I dared to critique canon, right? That I was a iconoclast. And so I got into some trouble, and then I kind of let it go. And then last year, almost exactly a year ago, I got invited to speak at a Extreme Tuesday, which is a fantastic meetup, London-based meetup, one of the oldest agile meetups in the world, and is now online, of course. And they said, look, we're talking about Solid as a topic. You did this talk a little while ago. It'd be great if you came along and spoke a bit about that. And one of the organizers gave me this brilliant challenge. He said, if you were going to replace Solid, what would you replace it with? And there's like a premise there, like, are there universal principles at all? Like, is that even a valid question? And if there are, what might they be? And I just thought this was gorgeous, this question. And obviously I've thought a lot about software over 30 years. And so I came up with my own 5. And I started with a word and worked backwards. So it's called a backronym. And I deliberately wanted a word that was kind of like, what's the opposite of solid, you know, and macho and all of this kind of software craftsman kind of mindset. And so Cupid is, you know, this Greek god or Roman god of love and joy and, you know, connection and relationship and all this stuff. It just felt to me like the opposite of solid. So I started with Cupid and then had the fun of choosing which characteristics went against which letter.
Yeah, actually, I had to look it up as a non-native speaker, what Cupid is, so I thought that was quite interesting. So let's go through your criticism of the SOLID principles. So first, SOLID is an acronym. So what does S stand for, and what's your problem with that? with whatever it stands for.
What's your problem with this? So the S stands for the single responsibility principle, which, you know, when you say it out loud, it sounds pretty obvious. Code should have a single responsibility. But then if you look at the kind of the narrative that goes with this, if you like, it struck me as well. So in the talk, what I do is I replace all the names with my own name, and I call this the pointlessly vague principle. Right. So, in other words, single responsibility doesn't mean anything. So, doing your accounting is a responsibility, right? Adding up the values in a transaction ledger is a responsibility. ETL, extract, transform, load, is a responsibility between databases, but so is extract, but so is so is the process of reading a single row within that extract. And so, responsibility gets a little bit vague. And also, when you look at the text, what they say is code should have one and only one reason to change. And that's the idea of the responsibility. And again, the thinking is, and I'll give you a couple of examples. The thinking is, let's say I have a component on a screen. The UI part of that code should be separate from the data in that, or the logic in that code. So if I've got something on a screen that's presenting some values, then the bit that does the value should be different from the bit that does the rendering. Now, which again sounds great when you say it out loud. In practice, what this tends to do is create an artificial separation, and typically too early. So it's a classic premature optimization, but this time it's a premature optimization of structure. So it may well be that actually I want all of the code for that widget or for that screen element to be together. The behavior, the integrations, the look and feel, the callbacks on the any events that happen in the UI. I actually want all that code together because it's changing together. Okay, and because it's changing for all kinds of reasons. It's changing because typically you don't the trivial example is, if I want to change the color of a widget, I shouldn't have to be looking at the business logic. But that kind of change really rarely happens compared to I need to add a new field. At which point I'm changing the layout, the content, where it's getting data from, some calculations. I'm making a change all the way through. And I spent a bunch of time in the late 90s as a contractor working on systems. This is the early days of enterprise Java, where you would spend your day typing getters and setters. You would get a value from a database and put it in a DAO. You're smiling because you remember this, right? You put it in a DAO, data access object, and you'd write a setter and getter on that to put it into a entity bean, and a getter and setter on that to put it into an interface, and a getter and setter on that to put it into a servlet, and a getter and setter on that to put it into a JSP. And finally, and all of this was pointless, just wiring, because you had this completely militant separation of concerns. Whereas if you have all this stuff in one place, you just get a value, stick it on a screen, you're done. And in fact, what I actually wrote at one point, about 99, I wrote, so Java had this thing called dynamic proxies, which meant you could create dynamically the implementation behind an interface. And I wrote a couple of dynamic proxies that made this whole thing go away. And you could just put a value in and it would appear on the screen. And I was told by the person leading the project, it's far enough ahead now I can tell you this, I was told that we weren't allowed to do this because too many people were making too much money writing getters and setters. Right? There were 30 contractors charging a whack of a day rate, and they were all doing this, and my little bit of code would make 90% of that work redundant. And I must never speak of it again. So the idea that you should separate out things like UI and business logic may happen at some point, but don't do it because it's a rule. And likewise, the idea that code should have one and only one reason to change is nonsense. You can give me one line of code, you can give me one statement, and I can give you 5 different reasons why that statement might need to change from 5 different stakeholders.
And it's hard to predict what kind of change will happen, even though I think
it could be a compliance change, it could be a security change, it could be a performance change. We're going to make this for loop into a recursive function because something else is happening. It could be a functional change, like a business rule change, but that's only one of many types of change. And so to say any code should have one and only one reason to change is not understanding why people write code.
Yeah, even though I think it's interesting because what you said is you can predict a certain type of change, which is there will be a change to the business logic, and that will be across layers usually. So it's maybe not a good idea to have that layering. I mean, that's the point that you made, and in a way you're predicting change. Therefore, I think that's just interesting. and you know, I couldn't agree more. So maybe we should go over to the next principle, that is for the O. So what is that principle, and what do you think about that principle?
So the O is really interesting. So O is the open-close principle, it's called. And there are two versions of the open-close principle. So it depends who you ask, right? So Bertrand Meyer coined the term open-closed principle, but the way it's used in Solid is different from his definition. I'm not going to get into the semantics of it because I will get it wrong, and a bunch of people will jump on me and say, no, that's wrong. But basically, there are two definitions, and they're wonderfully inconsistent with each other. By and large, though, this again, let's look at the historical context for this. This was in a context when OO programmers thought that there would be a market in classes. So I could sell you a library of C++ classes that might be some financial pricing set of classes, or some healthcare patient record set of classes, or some domain-specific set of classes. And you'd go and buy this bunch of classes, and you'd adapt them to your particular context. And so what Bertrand Meyer was trying to do, I think, and certainly folks around that time, was to say, look, let's be very clear about the degrees of freedom you've got. If you're going to start messing with someone else's source code, it should be really obvious which things you should be changing and which things you shouldn't be changing. And again, that makes a lot of sense, right? So the idea is it should be, and the phrase is, the pithy phrase is, open for extension and closed for modification. So in other words, you don't change what the class does that you bought in the class library. You extend it and change its behavior by extension. And again, this comes from a world where you would write code once, and then that code is now set in concrete, right? If you want it to do something else, you extend it and add new code. And you can see this in the tools of that era. So the prevalent version control system around then was CVS, which is the forerunner to Subversion. And CVS is file-based. So the idea is with CVS, when you change a file, or when you change a bunch of source files, each file maintains its own change history. And so for instance, if you rename a file in CVS, it loses all its history. It thinks that you've deleted the old file and created a new file with new history. So because it was, and this isn't a bug in CVS, it was a design choice. Right, you didn't rename stuff once you had it. And then 1996 happens, Martin Fowler's refactoring book, and the concept of refactoring lands, and people start renaming all over the place, because it turns out that names aren't set in stone, and a name reflects your understanding at a point in time of a situation. And so, I might call something a customer to start with, and over time I want to rename that customer to account holder, because actually what I'm doing really is managing their relationship with an account. If I do that in Java, I change the file name of the class, because in Java the file name is tightly coupled with the class name. Likewise, the package name is a directory structure. So if I rename a package, I'm moving an arbitrary number of files through an arbitrarily deep file system, and CVS and Java did not get on at all, or CVS and Java refactoring did not get on at all. And that was one of the forces into Subversion. Subversion was written by the folks who wrote CVS as a next generation in response to languages like Java coming along and saying class name equals file name .java, and refactoring is normal. So, and again, refactoring back in the 90s was like manually going through a bunch of steps that Martin Fowler had outlined in a brilliant book of patterns and techniques. And now it's shortcut keys and an IDE, So open closed then, to get back to the question, open closed is about taking some fully baked code and having rules to change that code. What I'm saying is, again, you were doing the wrong thing. Okay, so what we would do now is change the code. If I want different code, I change the code. And I do that fearlessly because I have version control and I can look at previous versions of the code. And I have automated code examples that guide my design. I use example guided programming or test driven development, as some people call it. And I often write additional automated tests as well to give myself more confidence. And all of that together means that I can relatively fearlessly change code. So all code is open and closed at all times. So again, this is what I mean by neither necessary nor sufficient. The context in which that's good advice is no longer a valid context.
I think that's a very good point, and it seems that we are somehow, those principles are, as you said, stuck in the OO understanding of the 90s. There was one remark by Sven Johan in the chat, and he said that Kevlin Henley has a talk, Solid Deconstruction, which seems to be along the same lines that of the discussion that we are just having right now. I will dig it out and put a link to it in the show notes.
That is, by the way, let me say, that is a fantastic, he did a series of those. So what Kevlin tends to do is, I do it a bit as well, is he'll take a talk and he might give it a number of times, and each time it's just a different riff. You know, so he'll have the same slides, but he goes off on different stories and different tangents. And there are a number of versions of that Solid Deconstructed talk, and they are all brilliant, you know. And he is way more academic and way better researched than me. You know, I do this as a programmer. He does this almost as a software historian. You know, it's astonishing the level of detail he has in there.
So it sounds as if that definitely gives another perspective. Sure. But we shall probably continue our discussion. So what's L, and what do you think about the L principle?
Well, so L is Liskov substitutability, and this is Barbara Liskov, the legendary Barbara Liskov. And I see there's a number of ways to tackle this. The first is that most people misunderstand it. So Liskov substitutability principle says that any subtype should be substitutable for its supertype. So in other words, as something gets more specialized, I should be able to plug it in anyway. In class-based OO, people tend to, or class and interface-based OO, statically typed OO, people generally replace the word type with class in their head. So think about subclasses. But subtyping is, you know, when you start getting into type theory, is a vast space, right? It's a much more involved and intriguing space than inheritance-based class OO. So let me just start there. The next thing to say is that she presented that principle almost as its own counterexample, right? So in other words, if you talk about substitutability, if I create a subtype, I create it for a reason, right? I create it in order to introduce some new behavior or to change some behavior. So by definition, no subtype is substitutable for its supertype, right? Alistair Cockburn has this brilliant trivial thing. He says, you know, type S, print little s. Type T extends S, print little t, fail. You know, and any subtype will necessarily not be identical to its supertype. So substitutability kind of means that it should kind of not be too surprising, right? So if I have a something that is a subtype, and you can put this in the context of, say, command query, right? So if I have a type that has a method on it, or that has some behavior on it that's a query, and then I have a subtype that then is mutating, so it's a command, that's going to largely be surprising to someone naively using that. A great example early on, there was in the early days of the web, and particularly of blogging and personal websites. There was a great story of someone complaining to Google that they'd stolen his website. And they were saying, we can't steal your website. It's a website. He said, no, you've stolen my website. All of my pages have gone and they're all in your search. And he said, that's impossible. That's not how the web works. And it turns out that what he had it rolled his own blog and his own website, and he had a link on each page called delete. But it was just a get. It was an HTTP get. So what would happen is the spider would crawl the website, lifting every page into its cache and deleting as it went through. You know, if you're going to write a website that violates the semantics of HTTP commands, you're going to surprise people. And it's that's the kind of the energy, if you like, for LSP. My counter to it is this: is again, it's a historical construct. Is when you talk about subtypes at that point in history, by and large, and I was doing this. I did this at college. I did this in my early, probably first 10 years of my career. Is all of object modeling is ISA and HASA. So ISA is subtypes. Cat is a animal. Tabby is a cat. Or HASA. Cat has a collar. Cat has a tail. And that was all of OO, right? All of object modeling, entity modeling. And then, of course, as we learn more, we realize that the ISA and HASA is again a historical book. Most things are not direct descendants of. Most things act like a, or in fact, most things act like a some of the time, right? Can sometimes be used as a. It's a much better way of describing the relationship. You can sometimes uses a rather than contains. And so we can now, we model these in our code with composition. And this is why composition has, by and large, replaced inheritance as a modern OO modeling tool, because you can compose things temporarily. You can kind of borrow a service, whereas you can't subclass something temporarily. You either are or you're not a subclass. And so again, it's great, but it's meaningless. Right? It doesn't make any sense to model things as ISA and HASA, and so rules about how best to do that are, I call it the Drucker principle. So Peter Drucker says, there's nothing more wasteful than doing well something that shouldn't be done at all. So what LSP does ISA and HASA really well, but so what?
What I thought was interesting, was in particular interesting, is how the Liskov substitution principle. I mean, it's basically almost a mathematical principle, and it is based on sort of type theory. And you said that it should be replaced by there shouldn't be any surprises, and that's of course rather subjective. And it's
yes, exactly.
And I think that's just something. I mean, it makes a lot of sense, but it means that we are talking about something different, right? I mean, about.
Well, yes and no. So when you say subjective, so I think a word I might use instead would be tacit. So my assumption of what surprising would be, if you don't know it, that's tacit knowledge. So you can use things like design by contract to express what you think surprising is.
Okay, yeah.
So if I now have a type system that also has contracts in it, for instance, then I can say what surprising subtyping would be. And I can put bounds on that. So I can say, this calculation should always come back with a number, and I start returning strings, and I can have a contract on that says, wait a minute. And the contract could even be in the type, in the signatures itself. If you think it's a signature on a statically typed method or statically typed function is itself a form of contract. It's saying, I promise to only ever receive or return ints or whatever.
So the next letter would be I. So what about that principle?
So this was the easiest one. I call this the fish in a barrel thing, right? This one was too easy. So the I is interface segregation principle. And this says, if it says clients of something should only need to care about what they need to care about. So let's say you have some class, some type, and it has hundreds and hundreds of methods on it. And I want to interact with it. and I only need to interact with a handful of those methods, I shouldn't need to even know that the other ones exist. And the example that again Bob Martin uses is some code that he picked up at Xerox, and there was this God class, this thing with thousands of lines called a job, and this job would move around into all different subsystems and have hundreds of methods on it because it was used in all different ways. And he said what he did, and it makes a lot of sense, is he introduced a load of interfaces, narrow opinionated interfaces, and started to hide, made the job implement each of these interfaces and then hid the job behind the interfaces. And now in each of the contexts it was being used in, they would only see the narrow interface.
Mm-hmm.
And he says, so if you have a big class that's doing way too much stuff, then smaller interfaces, segregating it into small interfaces is a good idea. And my counter to that was, if you have an object, well, a class with hundreds of methods on it, how did you get into that mess in the first place? Right? Practically anything is better than that. And so I don't think of this as a principle. I think of this as a strategy. It's a pattern. If you're in this situation, breaking this thing, identifying sets of methods that go together, giving that a domain specific name, and then introducing some kind of separation, either a superclass or a composing or hiding it in some way. It doesn't need to be an interface that it implements. It could just be a class that it delegates to or delegates from that has that narrow opinionated, right, which is great. But that's not a design principle. That's a way of getting out of that in the first. How do you not get in there in the first place? So I call this the stable door principle. I shut in the stable door or the barn door after the horse has bolted, right? So, how do we keep the horse safe in the first place? So that's really what I'm interested in. So yeah.
Okay, great. So the last letter is D. So, and then we are done. So what is D, and what's your problem with that?
This is dependency inversion. Dependency inversion says that you should you should not. He talks about, I can't even remember exact wording of it, but it's about higher and lower level dependencies. So lower level things shouldn't depend on higher level things, or the other way around. And the reason I struggle to remember it is that's not how I think about code. Right. Again, this comes back from a 90s, object hierarchy mentality. And you have hierarchies of things going more and more lower level, a higher level, lower level. So I think of code as components collaborating with each other. And some of those components are going to be closer to the UI and to the user interaction, and some of those components are going to be closer to technical services like databases or networks or cloud stores or whatever they might be. But they're all going to be independent first-class collaborating components. And really, so dependency inversion led to, and I was part of this mea culpa, right? I was part of this movement as well. It led to an explosion in the idea of dependency injection, and dependency injection frameworks. And like the epitome of this was again J2EE, where you had reams and reams and reams of XML, many redundant classes or unnecessary classes, and all services were looked up through a naming directory called JNDI. And JNDI, we all thought JNDI had been put out to pasture decades ago until it emerged recently as part of the Log4j. the Log4Shell bug, it turns out, is some weird JNDI quirk. But so we got used to this idea of a service locator pattern and dependency injection. And then Spring came along, which was kind of supposed to be an antidote to J2EE that was much, much lighter weight, and then it became its own big behemoth. But effectively, you ended up wiring up code through XML or wiring up code through Java attributes. And you were now programming in text rather than programming in code, which got really frustrating. And so my kind of poking the bear, if you like, of dependency inversion is it's one of these things that's very easy to have too much of. Right? For me, a genuinely useful principle, more should be better. Right? Have compassion, be kind. Right? More kindness more compassion is usually never a bad thing. More empathy, have empathy is a good principle, right? If you have more empathy, you're likely to do better, right? If you have more dependency inversion, you're likely to just have more unnecessary interfaces.
And that's probably why Cupid is already a better acronym. But before we talk about that, there is this principle that I think you invented, which is fits in your head, and I think it's a very powerful one. So before we talk about Cupid, can you talk about that and what the reasoning behind that is, and what it actually means to you?
So yeah, so this is some work that I've been. Right. So one thing I have is very, very slow output compared to what I'd like it to be. So around over 10 years ago now, 2010, 2011, I was working in a trading firm with an insanely high performing team. It's the most high performing team I've ever been in. I suspect it's the most high performing team I will ever be in. And I was there for about 1.5 years in that team. I was there about 2.5 years in the organization. And I had what I can only describe as culture shock in this team. I went through, I'll be serious, I went through a depression. About 6 months in, I was like, I don't know how to write software. I don't know how to write software. I'm in the wrong job. Well, I thought I knew how to do this. Everything they're doing is completely alien to me, countercultural to me. I don't understand any of it. And I need to quit. I need to go back to my safe little agile bubble where I understand the rules. And my wife, who's brilliant, she said, look, I'll tell you what, give it another 6 months. If you still feel like this at the end of the year, then quit. So, okay, great. And a couple of months after that, I kind of turned a corner. And so what I tend to do is when I'm in any situation, I'm three people. I'm myself, doing my day job kind of thing. I'm then observing myself or observing my context, observing the team and thinking like, what's going on here? So I'm a continual optimizer. Right? I'm looking at things and how can I tinker with this? And the third part of me is the teacher is how could I articulate this to someone else? And what I started doing towards the back end of that year was articulating how this team was different from anything else I'd ever encountered. And initially I called this accelerated agile. I also called it patterns of effective delivery. And for the last 10 years or so, I've been calling it software faster. And I have a very, very slow moving book on Leanpub called Software Faster. And one of the kind of core principles, if you like, from this work is called fits in my head. And the principle of fits in my head is it's really simple to describe, but it has really profound implications. So it's this. You can only reason about something if it fits in your head. Okay, if you can get an idea in your head, you can reason about it. The contrapositive of that, for logicians, the converse of that, if you cannot fit something in your head, you cannot reason about it. Now, it turns out that most code bases, most domains, most product ideas, most whatever, don't fit in our heads. And so what we have, and to a large extent unconsciously what we have, is techniques for actively ignoring vast amounts of this so that we can just focus on a bit that does fit in our head. So TDD, for instance, is a great way of making a tiny subset of a big code base fit in your head. I'm just going to think about a little model client here that's not connected to anything else, that takes that bit of code that's not connected to anything else and makes it do stuff. The fact that this code lives in an ecosystem of loads and loads and loads of other code, I don't need to fit that in my head. Now, the challenge is this, is what some of these techniques are about being able to ignore the chaos and the noise and the mess. And some of these techniques are about simplifying the chaos and the noise and the mess. And you kind of need both. Right? You can't just go in and confront the noise head on. It doesn't fit in your head. It will overwhelm you. But you can't just take the painkillers. Right? You can't just do TDD and a big, ugly mess of a code base because you'll just get a big, ugly mess of a code base with tiny pockets of TDD code. And so you need to have both. And the system dynamics folks calls this shifting the burden, this pattern or this archetype, which is that you need to understand that there's part of it is some kind of pain relief. And part of it is some kind of restorative. So for instance, say you have long-term back pain. You can take painkillers so that you can now move your back. You then also do exercise to strengthen your back. Right. And as long as you do that over time, your back will get stronger. You'll need fewer painkillers. You'll need, and then you get into a maintenance mode. If you don't do both of those, you become dependent on the painkillers. And what we've done is we've become dependent on the painkillers. Like I can take literally millions of lines of code, and I can drop something like IntelliJ on top of it, and I can navigate that code. So a really good IDE with a really good indexing and AST system built into it is a fantastic painkiller. It won't make the code base any simpler, right? It just means that I'm now more able to find needles in haystacks. And so Fits in My Head is about being deliberate and mindful about which things you're doing are making the world simpler and which things are making it tolerable.
Yeah, so that's, I think it's very interesting to see how that simple principle has so profound implications. The other thing is what you just said is that even people like you sometimes have self-doubt. So thanks for
sometimes is doing a lot of work in that sentence.
Yeah, so thanks for sharing that, and I think it's a powerful statement. So if you do have self-doubt whether you're in the right industry, that happens to I guess all of us from time to time.
To be fair, I only had 25 years experience at that point, so it was
still a junior, yeah.
Still a beginner, yeah.
Okay, so let's talk about Cupid now. So Cupid obviously is again an acronym. So we'll go through the letters again. So C is the first one. So what is it, and why is this a good principle in your opinion?
So very briefly then, because I don't want to. I mean, this is exactly what I'm going to be talking about at the OOP keynote. But by and large, so Cupid it's deliberately not principles. Because principles are rules, right? Rules to live by. And the problem with principles is they act as a boundary. And so you get kind of solid police. And typically solid police are people fairly early in their career who've gotten hold of this thing and they're going to take this in. And so, the new person joins the team and they've been there like a few days and look at this code and they're going, that code violates SRP. This code violates LSP. This code, you're in violation. They're handing out parking tickets to to code, right? And I'm not a fan of that mindset of the you're in you're with us or you're not. And they call those bounded sets or bounded communities, where the point of the community is to guard the boundary. You've got in groups and out groups. So what I wanted instead is properties or kind of characteristics. And you can be more of this thing or less of this thing, but you're never outside and you're never done, right? It's not binary. It's a scale, and then it's a choice. It's up to you how far towards that center you want to move, whether you want to at all, how you want to trade that off against other criteria you're looking at. And so all of Cupid are criteria. They're properties of code that I think makes that code a joy, makes me happy to work with that code. So let's just start there. So C is composable. So code that plays nice with other code is just nicer to work with. And code that plays nice with other code, I find easier to write because I'm always writing it. It's, this to me is the very ethos of TDD, is you're writing code to meet the needs of other code. So you start off with the other code. You start with the model client. They call it a test, but I think of it as a model client. And you start with the model client and you say, right. And even writing the model client is, I'm sure you've had this experience as well, especially when you're pairing, is you discuss the API.
Right.
What would be a nice way to do this? The example I always go back to is database. Right. So there's, connect, query, close. Right. And so I say, right, we're going to write a database API, and we're going to go connect, query, close. Then we look at each other and we go, who's going to remember to close? Connect, query, walk away, right? How about try, connect, query, finally close? Yeah, okay, finally. That'll work, yeah. And then we look at each other and we say, how often do you think someone's going to bother to write that?
Mm.
And then we go, okay, what about if we just had it query? And the query, our implementation of query does try, connect, query, finally close, right? And we take that responsibility. What if we did that? Well, okay, now there's trade-offs. One of the trade-offs is that we're creating a new connection every time. And if you're going to loads of queries, that might be expensive. Okay, so maybe we could have a caching version of this, or some kind of query pool, a connection pool, so that would mitigate that. And now what are we doing? We're trying to write one line of code in one test, and we're already having some quite involved design conversations about this database query. We haven't even got to that side yet, right? And so the joy of writing code to be composable is that you're designing it with the end in mind. That's just one tiny example. Again, with all of these, one of the things I wanted to do with this as well, with each of the 5 of Cupid, is it's kind of layered. So I can chat to you very briefly about sort of what composable is, but then we can get into massive conversations about composability of distributed applications, composability in asynchronous systems, composability in message passing. There's many contexts in which. So there's a lot more to it. But by and large, write code that's nice, that's easy to use with other code.
So.
And again, more is better, right? That if you write code that's really easy to use with other code, I'll be happier.
Right, yeah. So in the chat, Konstantin Takchenko, I think that's how you pronounce the name. Sorry if I didn't get it wrong. Right. He said, I think there is no universal principle. Principles only can help us to prevent making wrong decisions. Would you agree, or anything that you want to add to that?
I would say I totally agree with the first part of his. There are no universal principles, although that itself is a universal principle, right? So, be careful what you say. I think it's not necessarily about telling you what not to do. It's, for me, principles are about helping me be more explicit about trade-offs.
Okay.
So if you and I share a set of principles, it means we're working off the same rules. And so, for instance, dry. Dry is a great example. Don't repeat yourself as a design principle. So dry is great if you look at it in isolation. If you look at it as the dual of coupling, right, then suddenly, wait a minute, it's not so great. So I might say that so I've got 2 components and I have the same code repeated in both components, these independent components. As soon as I pull that out into a shared piece that they both use, I just coupled those things together. Right? That's not a good thing or a bad thing, it's a thing. What makes it good or bad is the context in which that coupling happens. If this code looks similar by coincidence for now, and if you look at the forces on those 2 pieces of code, they're going to go off in very different directions, then extracting that repeat yourself at that stage is premature optimization, and it means I'm going to get into a world of hurt. But if instead I end up with 28 different cookie cutter versions of this thing and they're all the same, and I could have factored it out much sooner, then and I have some business change that I have to make, some legal requirement, and I only remember 27 of them, I'm now breaking the law. Right, and absolutely pulling that commonality out much sooner before it got to the 20s would have been a good idea. So principles are useful in the context of discussion and trade-off, but they're not. Konstantin's absolutely right. Taking a principle as an infallible, inviolatable rule is generally that's where kind of dogmatism comes from.
And maybe that would also be an idea to like talk about not principles but rather trade-offs, like you just did, right?
Absolutely.
That there is this trade-off between dry and independence and things of that nature, and then it's clear that there are 2 ways to do any specific thing.
Sure. What I would say is I did a series of talks on exactly this topic a few years ago called Decisions. And there's different variants of it that look at things like operations, architecture, team habits, and so on. So what we'll do is after this, I will find some links to some versions of decisions. We can put those in the notes as well.
Yeah, that's perfect. So next would be U. So what is U about in Cupid?
U is a Unix principle, a Unix philosophy. And Unix philosophy is simply this. It says each command, each thing should do one thing and do it well. And then the other part of it is, and they should play nice together. So you've got this kind of composability thing in there as well. But the Unix philosophy is that each command does one thing well. Now, Unix has stood the test of time, right? Unix is 50 odd years old. In fact, Unix and I are about the same age. We both started in 1969. So, and Unix is a lot more well known than me. And part of I think part of its longevity and success is this incredibly simple design philosophy in it. So in Unix, everything's a file, right? Files are files, directories are files, block devices. You used to put stuff on tapes. Those are files. The network is a file. Other computers are a file. Memory is a file. Since the Slack, the proc file system, the process table, running processes are a file. And so you can use this file hierarchy paradigm for practically anything. Inside files, Unix says you have text and not text. And there's lots of commands that are really, really good at dealing with text. And that's it. So, and again, this sounds a bit like SRP, but this is about how you're used. Yeah.
So next would be P. So what is P?
I think P is probably the biggest topic of all of these five. And it's about predictable. So code should be predictable. And what I mean by that is I should be able to look at code and have a good idea what it does. If I'm looking at code and I can't figure out what it does, or if I run that code and it does different things each time I run it, and it's not designed to do different things each time I run it, that's unpredictable. If it has crazy memory or CPU or network characteristics when I run it and it goes all over the place, that's not predictable. If it has unpleasant emergent behavior, that's not predictable. So predictability is, I describe predictability as a generalization of testability. There's Kent Beck talks about passes all the tests as one of his 4 kind of rules of design, and I'm like, yes, even when there's no tests, even when the test is, does it do what I think it should do? Right? If there are no automated tests, that statement should still be true.
There is actually that's probably a good question. So I guess it's concerning the Unix principle. So Matt Skippy on YouTube asked, how is do one thing well any better than single responsibility? Isn't the issue identifying what single means?
So yeah, and this is absolutely a great question. This is where these properties start to play into each other. So we can say, does one thing well, and the composable, the C and the U work together. So if you're doing one thing well, but that one thing is so fine-grained that I always have to use 3 other things with you, then you're not very composable, because you're putting cognitive load on me to know that those other 3 things exist, are useful. Back to the example with, create connection, run query, close connection. Right? If I know that dance has to happen every time, then the querying thing isn't as composable as something where I don't need to. So the granularity is about how this thing is going to be used. It's the context in which, and that plays into the composability piece.
Okay.
Great question.
Cool. So there is, I think I is missing from Cupid.
Yeah. So this is a great thing about making up a backronym. Is I had lots of candidates for each of the letters, and I was the one that had the most candidates. I should probably write an article about the short list, the other things that didn't make the cut. What I went with is idiomatic. So idiomatic means, and this again is fits in my head, is one of the biggest critiques I get of fits in my head is like, whose head? You know, we're all different, we're all subjective, you know, how dare you assume what goes in my head, blah. And some people get quite defensive about that. I have a very clear definition of the my in my head. It's someone who understands the idioms of whatever it is we're using. So if it's C++, they understand what good C++ looks like. If it's Rust, they understand what good Rust looks like. But not just the language, but, you know, the tool chain, the libraries, if I'm going to do HTTP stuff in Go, how would I do that? And this is where you get into something like Node.js, where it's very unopinionated, because there's just this vast number of options for practically anything you might want to do, which again is double-edged, right? It's this wonderful Cambrian explosion of opportunity. It also means that, you know, if you do not have opinions, then you're going to get all of that stuff in your code base. You're going to have Vue.js pages and Angular pages and React pages and Redux pages and so on. And so you need to start getting very opinionated. So idiomatic fits in my head is someone who understands the idioms and knows how to code, right? So an experienced programmer. And the rule I added recently, and isn't me. So in other words, you're writing this for someone else, but we can describe what that someone else. You're not just writing it for someone who's never written code, and you're not writing it for someone who doesn't understand what. So, for instance, idiomatic closure is really unfamiliar to someone with a C-shaped language background, with like a Java or C# or C++ type background. Clojure, you know, Lispy languages just look really unfamiliar. If I try to write a Lispy language for someone you know, who in the intended audience is a Java programmer, I'm going to put all sorts of stuff in there that a Lisp programmer, a Clojure programmer, is going to say that's not what we do. Right? That's not what Clojure looks like. So the assumption is that the person I'm writing for knows what idiomatic code looks like in that technology, and I'm writing for them. And then might be future me, you know. But there's an empathy element to this.
So finally, there is D. So what does that stand for?
I'm going to turn this around. I think you are way more qualified to talk about the D than I am. This is domain based. So this is that your code, you know, joyful code that is joyful to work with, uses not just the language of the domain. And so I can describe domain problems or describe domain algorithms or describe domain processing to you, and you can literally see those words in code, right? That's part of domain based. But a much bigger deal for me is the way you lay out the code. And a lot of frameworks are like real, what's the word? Well, it's the Rails, right? And again, not banging on Rails, it just happened to become very popular. So that's what happened everywhere. You go into a Rails app. In fact, the Rails skeleton app has, like, you know, controllers, model, views, helpers, whatever else it might have. And that's not how I want to look at code. Right? I want to look at login. I want to look at account management. I want to look at payments. I want to look at patient scheduling, right? And in there, I want to see all of the stuff to do with patient scheduling, the models, the views, controls, all of the code. And again, this comes back to that premature separation of concerns thing. So most, certainly most Webby frameworks are very SRP. You know, they impose their architecture on your project layout. And domain-based code should mean I look in one place to solve one problem.
So Skippy just added a remark. I guess that is why naming is so important. It's the only language tech-independent thing to do. However, and that reminds me of ubiquitous language and the DDD stuff around that. But what you just described is actually more. It also says that the organization of the whole thing should be according to the domain. And then he asked a very interesting question. So I'm wondering how you can answer that in the time that still remains. And that is, what do you suggest to identify things that belong together? Isn't this the same question as what a unit test is testing? And that's probably the question. So what is a module, and how do we figure out what modules are?
Right, right. And my stock, it's a great question. My stock answer to this is I don't know yet. Right? So if I make it easy to move code around, and I get into a mindset where I don't mind moving code around, I'm confident moving code around, then it will sort itself out. So in other words, I might start out with all of my app in one big file because it's tiny and that file fits in my head. Right? I can reason about that file easy enough for fitting in my head. But then as it grows, I will want to separate it into chunks. I know enough about programming that I don't know what those chunks will be yet, right? Because I don't know yet what I need this code to do. And Eric Evans says this beautifully about domain-driven design. You're not modeling a domain, right? Domain modeling, DDD is not modeling a domain, because there's a wonderful phrase, all models are wrong, right? You're modeling a domain in order to, right? So you're modeling a domain to solve a problem, to build some capability, some service. And the model of the domain is entirely about meeting that need. And I don't know what all the needs are. So I start simple, and I move things around fearlessly. And I do that using TDD, using good version control, using good tools. And the code ends up the shape it should be. And there's a wonderful quote from Douglas Adams in Dirk Gently's Holistic Detective Agency, which is a fantastic book that he wrote after the Hitchhiker series. And there's this detective called Dirk Gently, and he does what he calls holistic driving. And holistic driving is he gets in the car and follows someone until he sees someone else who he thinks he should follow more, and then he follows them. And he says, I never end up where I thought I was going, but I always end up where I needed to be.
Yeah, that's a good one.
Right?
So and I think what you just said is actually a very good point. Maybe that's another, I don't know, principle or something that you could add into your acronym. Like, no matter what you're doing right now, it's going to be wrong in a few years, in just next week or in very. Yeah, and because I think that's also something that we still get wrong. We are still trying to figure out how to do something that just sticks there eternally, and that's just a wrong concept. So, final question. So these are some ideas, some concepts. What kind of feedback are you looking for?
That's a great question. So I was actually going to step back and say there's another principle, or another underlying pattern, if you like, from the Software Faster work, the Fits in My Head piece, that I call a software half-life. And a software half-life is, given any code base, after how long will half of that code have changed? Be either rewritten, deleted, changed beyond recognition. And what I noticed with this team I was working in is that the code half-life was like weeks. Literally, quite a large, complex algorithmic trading stack. Half the code would change in a matter of weeks. And no one believed me. And then there's a brilliant article, and again, we can link to it afterwards, which is about how Google adopted automated testing. And there's just a wonderful throwaway sentence in the middle of this article. And Google's got billions of lines of code, right? Eye-watering amounts of software. And they said 50% of the code in Google changes every 4 weeks.
Wow.
So the half-life of code at Google, 60,000 engineers, billions of lines. Half the code in that organization changes every week, every 4 weeks, right? And so then if you start thinking of wanting to keep a short software half-life, then you start to think differently. Because now you're thinking, okay, half the code I'm writing won't exist in a few weeks, and I don't know which half, right? So you're writing it both to keep and to be disposable. And those are interesting forces to resolve. To answer your question, what feedback am I looking for? So Cupid as an idea has been around for nearly a year now, and I'm starting to get some really interesting feedback. One person hit me up on Twitter and said, I used Cupid as an end of year kind of, we had a bit of quiet time at the end of the year, and we're looking at our code base. It's big, complicated legacy code base. We're trying to kind of, engineer our way out of it. And he used Cupid as an overlay, if you like. And he said, right, so for a start, let's assess ourselves against each of, composable, idiomatic, etc. And then let's decide which of those we want to move towards for which code to gain the biggest benefit, biggest impact. And so which is so exciting for me. So people are starting to use this as a tool to simplify their code. The feedback, I would love to hear case studies. I would love to hear people using it. I would love to hear how you get on with it. I would love to hear how you introduce it, where and how you introduce it, what either positive or negative feedback did you get, what encouragement did you get, what resistance are you seeing. So anything about real life usage in the wild would be just super exciting.
Okay. I'm afraid that there are still a few questions on the chat, but we are already over time. So thanks a lot. Thanks a lot for explaining your Cupid and also Solid to us. And thanks for answering all the questions. And I'm looking forward to see you next week at OOP. And as I said, we will also be on at the OOP with our stream. So maybe you want to join us in the stream too. So thanks a lot, and have a great Friday and weekend afterwards, I think. Thanks.
That's it. Thank you very much. Thanks for inviting me on your show. I thoroughly enjoyed this conversation. And just to reiterate, I thought the questions we got on the YouTube channel were just brilliant. So thank you very much for everyone who posted.
Yeah, I can only second that. So the questions and the discussions on YouTube and on the chat are very important. So thanks a lot, and keep doing that. Okay, thanks. Bye.